This next question, a bakery makes two types of muffins, chocolate and banana muffins. The weights, C grams, of the chocolate muffins are normally distributed with a mean of 62 and a standard deviation of 2.9. Find the probability that a randomly selected chocolate muffin weighs less than 61. So that's pretty easy. We have C has a normal distribution with a mean of 62 and a standard deviation of 2.9. Okay, this is how we write it though. We write variance in the notation, but we use 2.9 in our calculations. And we're going to work out the probability that, I was going to use X there, but C is less than 61 equals, and let's use our calculator to figure that out. I'm using HP prime, but it works similarly on most calculators. So let's go to probability. This is a density rather than cumulative. Oh, it's cumulative because it's less than. So cumulative, normal, and for this calculator you type in the mean, which is 62. Oops. The mean, which is 62, comma, 2.9, because that's our standard deviation. And 61, that gives us the probability of less than 61. So we get that number. Now this is a multi-part question, so you want to use all these digits in further calculations. You either need to do some copying and pasting or write down all the digits. So let's write down 0.365, 11199, 6413, just in case we need them. But three significant figures, it's 365. Okay, nextly, in a random selection of 12 chocolate muffins, find the probability that exactly 5 weigh less than 61. So this is a classic switch to binomial. You're selecting a bunch of muffins, 12 of them. So that's going to be the n in your binomial distribution. So we say X has a binomial distribution. We're selecting from 12 objects, and the probability of a particular object being less than 61 grams is 0.365. But of course on the calculator we're going to use as many digits as possible to get it accurate. So we're looking at the probability X equals 5. And let's do that on the calculator. Okay, so now we're going to choose probability binomial density function, or binomial PDF on the TI-84. Okay, so we type in 12, comma, and this calculator I think I can copy and paste, and equals 5, so we're going to do comma 5, and we get this answer of 0.213 666 060 285, or about 0.214. We have the bananas now, so the bananas have a mean of 68, standard deviation of 3.4. The banana muffins, each day 60% of the muffins are chocolate, so 40% are bananas. Find the probability that a randomly selected muffin weighs less than 61. So we already have less than 61 for the chocolate. Now we need it for the bananas. So the banana muffins have a normal distribution of 68, and 3.4 is the standard deviation. Probability that a banana muffin is less than 61. Let's get that with the calculator again. So let's go to probability cumulative, normal. So we got 68, 3.4, and 61 again. And we get this tiny amount, which is in scientific notation, 0.019755557, 33888, or just 0.0198 to three significant figures. So we want to find the probability that in general any muffin, or random selecting a muffin from the entire group of muffins is less than 61. Then this probability is, well, there's a 60% chance it's chocolate. So we take 0.6 and multiply it by our answer from part A, I believe it was, 365, and then we add it to, there's a 40% chance of getting a banana muffin, and then this is the probability that a banana muffin is less than 61 grams, so we got to multiply these together. And of course use the exact amounts on your calculator. So we're going to do 0.6, oops, 0.6 times, and I've got the answer up here, plus 0.4 times this answer we just got, and you get 0.227. Alright, you can write all the digits again if you need to. If you don't have a copy and paste feature on your calculator, then you may need to write out all these digits. 9694, 27204, or approximately 0.227 to three significant figures. Okay, next, given that a randomly selected muffin weighs less than 61, find the probability that it is chocolate. Okay, so this is a conditional probability question. So we use the formula from the formula booklet. Probability of A given B equals probability of A and B divided by probability of B. So in this case, remember the given thing is always in the denominator. We're going to have probability of less than 61 given that, we're given that's less than 61, sorry. So that goes next. That's the second part. We're finding the probability that's chocolate. So probability of chocolate less than 61. So that's the probability of chocolate and less than 61 divided by probability less than 61, which is our answer from the previous question. Okay, that's 0.227. And probability it's chocolate and less than 61 is basically this part. This is the probability it's chocolate, and this is the probability that it's chocolate given its probability is less than 61 given it's chocolate. So we just do this part, right? So we can type it into our calculator. I can do 0.6, oops, 0.6 times, again, this exact answer up here, and then divide by this exact answer, and that will equal 0.965. Let's write them all out in case we need it for the last section. 1837, 27812, or approximately 0.965. In this next part, we're given a lot more information here. The machine that makes the chocolate muffins is adjusted so the mean of the chocolate muffins remains the same, but the standard deviation changes. The bananas don't change at all, the banana muffins. The probability that the weight of a randomly selected muffin from these machines is less than 61 is now 0.57, so this has changed. And we have to find the value of sigma. So basically it's the same calculation as we did back here, but now we don't know this one. This one's going to change because the standard deviation has changed, and this number here has changed. So we're going to use the exact same format and just solve for the missing value. Okay, so we're going to have 0.6, and this is probability that chocolate is less than 61. So we're going to have 0.6 times probability chocolate less than 61. Plus, this is totally the same, but we're going to use the exact number from our calculator, and this is 0.157. Okay, we can solve for this one here, and if we take let's do that in the calculator. Let's solve that. So let's do 0.157. Let's subtract this bit. 0.4 times 0.01. Oh, actually we have, let's get the exact value from before. That's what's this one right here. Okay, and we're going to divide by 0.6. That will solve for this, right? Well, actually, we can't do that. Let's just press enter and then divide by 0.6. Okay, so we get this amount here. So we get the probability C less than 61 equals 0.248 496 284407, or about 0.248. So we have this, and now we can find sigma by, actually we could solve this by graphing, or we can use this formula from the formula booklet, which is probably the better way to do it, because sometimes you need this formula for finding mu and sigma and solving simultaneous equations, which you can't do by graphing. So let's do that first. So we have this probability equals this. So this means, well, we know the mean is 62, and 61 is over here somewhere. Actually, I should probably write these numbers down here. Okay, so we're going to find the z-score from the formula booklet, which tells us how many standard deviations it is away from the mean. So we can do that with the inverse normal. So the z-score for that, let's do inverse normal on the calculator. Let's go to probability inverse normal. And we can do, type in the mean. What was the mean again? 62. Well, actually, we just need to, we need to use the standardized normal, right? So 0, 1. Okay, by this calculator does it by default, so you can just leave them out. And 0.248. So that gives us this amount, which is negative 0.6807,969. You probably only need these many digits, but I'll just write them all out to be safe. So that's the z-score associated with that. So this is negative 0.68 standard deviations away from the mean. Okay, so then we use this to solve for sigma. So we have that equals our x value, in this case is 61. That's the value we're talking about. The mean is 62. And then we have sigma here, so we can solve that. That's like sigma equals negative 1 divided by negative 0.681. So let's do that on the calculator. And we got negative 1 divided by our answer from before. And we get 1.47 is our answer. Okay, so that's the final answer to this question. I'm going to show you how to do it by graphing, though, if you're interested. So I'm going to go to the app here, and we want to solve that equals 0.248. So we're going to graph 0.248. Actually, let's use more of the digits. So 0.248, 49628. That should be enough. Oh, I'm going to do that in F2, but anyway, it doesn't matter. And we type this directly in there. So that is a cumulative normal. The mean is 62. The standard deviation is x, because we don't know what that is, and 61. So I click OK, and then I can solve this by graphing. Now that graph looks a bit messed up, so I'm going to have to zoom in. Let's go to shift plot. Our x values go from, so x is standard deviation, I don't know, 0, let's say 5. The y values in this thing are probabilities, so those go from 0 to 1, right? And let's go to plot now. There you can see the point of intersection. So let's go to function, intersection, and you see we get 1.47 as well.